Hello everyone, and welcome back to the IBM Personal Computer, the model 5150, the original personal computer. Last week we had a look at the Pascal Compiler, which is a compiler for the high-level Pascal language, which IBM made available immediately on release of the IBM Personal Computer. So that compiler was available from the very beginning. And as we were looking through the manual which came with that compiler, we discovered that IBM had rather big plans for this compiler. And they intended Pascal to become the systems language for systems programming on their personal computer, something akin to the role of the C language in the modern day. Now, when the personal computer was released, IBM was known mostly for its mainframe products, and they'd been a dominant player in the mainframe market, certainly in the preceding decade and for even longer. And mainframe programs at the time were programmed in a variety of computer languages. Two of the common languages in use on mainframes at the time were actually developed by IBM, and those are FORTRAN, which stands for the Formula Translator, and COBOL, which stands for the Common Business-Oriented Language. And so both those languages were invented by IBM for use on mainframes. Because of their existing mainframe customer base, IBM also made compilers for both these languages available for their personal computer. And so we'll be looking at those compilers today. Now, the first one we'll look at is the FORTRAN compiler. Now, if we look at this website here, WinWorld PC, which contains a lot of the diskette images for the early software for these IBM Personal Computer, we find that there is a version of the IBM Fortran compiler which we can download. And so here it is, version 1.0, the very first one ever released. Unfortunately, this software archive contains only the diskette images of the Fortran compiler. There is no manual, so apparently nobody's scanned in this manual or made it available in some digital form. And so this week we'll be unable to follow the steps in the manual to know exactly what to do. So all we'll have is the diskette images, but we'll try using those anyway. So let's have a look at the master diskette images. And so if we have a look here, I have them here in diskettes in master. You'll find, like Pascal, it comes in 3 different diskettes. And so the first diskette contains a program called for1.exe. The second diskette contains for2.exe. And so it looks very much like the situation we had in Pascal, where the actual compilation step is done in 2 passes, because each of these passes is a complex operation. As we can see here, the Fortran 1 compiler, the first pass, is 101 kilobytes. And so that's almost an entire diskette. And the second pass is another 87 kilobytes. And so just as in the case of Pascal, the compiler appears to be split into 2 passes. And then there's a third diskette, which comes with the distribution, which is we'll have a look at. And so that contains a Fortran runtime library, which we'll want to link against when we've compiled our program to an object file. And then we also have a custom version of the linker. When we were using Pascal, you'll remember that it suggested that we use the link version which comes with DOS, but so Fortran appears to come with its own version of the linker. Now, just as in the case of Pascal, it seems very likely IBM would have recommended that you make backup copies, and in particular that you make backup copies which contain versions of the command interpreter, so you don't have to keep switching disks when you're using these compilers. So I've gone ahead and done that exactly as in the case of the Pascal compiler, and so I have here backup versions of the Fortran compiler pass1 and pass2 diskettes. Let's quickly have a look at those. And so that is essentially that same program for 1, and in addition the command interpreter. And so we have the same for my second pass compiler, and then we have a version of the library linker diskette which contains the runtime library, the linker program, which in this case came with Fortran, and then once again the command line interpreter. And finally, just as in the case of the Pascal compiler, which we used last time, we'll want a working diskette to contain our programs, in this time in Fortran. And so I've also prepared a diskette which I'll put in the B drive, which contains some Fortran programs. Now, since we don't have a manual, there's no way for me to know exactly what syntax would have been and would not have been accepted by the Fortran compiler. And so, unfortunately, to try it out, it's a kind of a trial and error process. But I've actually gone ahead and written 2 versions of Fortran programs using general knowledge about the Fortran language, and trying different versions out, which I happen to know work with this Fortran compiler. And just as in the case of Pascal, I've also copied the Edelin, the line editor program, onto this working diskette so that we can use it and we don't need to keep inserting the DOS diskette to be able to edit the source code when we discover some problem in our source code. So we had a look at Edelin last time when we looked at Pascal, so I won't go into much detail in this episode. Let's just have a look at this simple Hello Fortran program and see what it looks like. And so here it is, and this is the structure of a Fortran program. So Fortran is a pretty old and idiosyncratic language. You need 6 columns here of white space unless you put a C in the first column, in which case the entire line is considered to be a comment. That's the first thing to know about Fortran, at least this old version of Fortran. Modern versions of Fortran don't have this restriction. But back in 1981, the compiler is very strict about not interpreting these first 6 columns. So that's a comment. This is a program statement to write that we're dealing with a program. And so we have a simple hello world write statement here. And this is a bit of a convoluted way. This is akin to printf in C, if anybody's familiar with that. So the way console I/O works in Fortran is the star here means the standard output. And this here is a format specifier. And essentially a format specifier is exactly like a format specifier in printf, except that the different codes which you can use, in this case it's an A, meaning alphanumeric, instead of what you would use in C, which would be a $S. So you can look up these codes and find them on various Fortran sites. And so here's the string which we want to print out. Now, one very weird aspect of the Fortran language is that the first column of any string which you print out to a standard output device isn't actually printed to the screen, but is taken as a control character. And a simple space means we want this on its own line. So if we haven't finished a line in the previous statements, we should start a new line and then print this code. And so this first character will not actually get printed out. The message which will appear on the screen will start here. And all this space does is to ensure that we'll start on a new line. If you want to continue on the same line, you would write a plus here, I believe. So these are some of the strange ways that this old version of Fortran behaves. And you essentially find that out experimentally. Anyway, let's quit this and see how our program compiles. So yeah, we don't want to change anything. And we'll insert the first pass compiler in drive A, which is this one, this copy containing the command interpreter. And so with B as our default drive, we can type A:41. And let's see what happens. So that's very analogous to what we did in Pascal. All right, so it asks us for a source file, and so we'll try our hello version. The object file name, that seems good. We'll not ask for listing, and we'll definitely not ask for assembly code listing. And we'll see what happens. Okay, so as I stated, I've gone ahead and done a lot of trial and error, and so I've found out that this syntax actually doesn't cause any errors. So if we have a look at what that first compiler did, you'll notice that it does something very similar to what the Pascal compiler did. We don't have our hello.object file yet, but we have these intermediary files. In fact, they're called pass something. So this leads me to believe that not only does the Fortran compiler look similar, it's probably even based on the Pascal compiler under the hood. All right, so again, in analogy with what we did for Pascal, we'll run the second pass compiler and hope that it'll read these files in and produce an object file. So let's insert the second pass in drive A and run it. So this program doesn't ask for any information. It simply looks at these intermediary files. All right, no errors detected. Let's have a look at what it did. And it appears to have produced a hello.object file, which is pretty good news. So that hopefully contains machine language for our source code here in Fortran. So the last step, again, in analogy with Pascal, is to produce an executable file by running the linker against this object file and linking it against the Fortran, this time, a runtime library. And so we have all of that on our library diskette, which we prepared. And so what we need to do now, oh, that's the B diskette. I wanted to show you what's on A, which is the actual linker program and the Fortran runtime library. And so now let's just run that. And let's assume that Fortran works the same way all the other languages did. So we can specify we want the hello object file, which is on our B diskette. Here it is. We want to produce a hello.executable file. That seems correct. We don't want a listing. And we'll simply assume that, that this Fortran compiler will have told the object file that we need to link with the Fortran runtime library. All right, no errors indeed. Let's have a look at what the linker did. And we have a hello executable file. So theoretically, that should run our source code in Fortran, which simply printed the formatted string hello world. So let's see if that works. Yep, that appears to have worked. Notice this slight little detail here. Because we started our print line with a space, which meant write a new line. Apparently, even though this line was blank, Fortran has still created a new line. So when we were running this in BASIC and Pascal, this hello world would have appeared immediately after the prompt. But here we have an extra new line because of this weird quirk in the formatting behavior in Fortran. But all right, so apparently we are able to use this Fortran compiler even without the manual. And due to a combination of factors. First of all, Fortran is a reasonably well-known language, and there are plenty of sources of information on Fortran. I inspired myself mostly with the Fortran 77, which appears to be the closest dialect to what this compiler accepts. Although some of the constructs of Fortran 77 still caused errors in this compiler, so it's not exactly Fortran 77, but it's reasonably close. So it's a question of trial and error really. And so, spending a bit more time, I've also gone ahead and produced a primes program in Fortran, which is a derivation of what we did in Pascal and BASIC before. So let's have a look at that program. There we go. And so that has a variable called prime count. Apparently this compiler doesn't like long variable names, so I'm not sure what the limit is. It's probably 6 characters, something like that. It can only supports short variable names. An important feature of Fortran is the common block. If you want global variables, you must declare them in the common block. Otherwise, they'll be known only locally. And so here we have 2 variables which are known only locally. So these are global variables, but these essentially they'll land on the stack. So logical is the Fortran name for Boolean. And this is simply to call a procedure. So there's a procedure further on in this program called writePrime, and we're calling it with the argument 2. And then here is our main loop, and so that looks a lot like what we had in Pascal, except that in Fortran we need to use line numbers like we did in BASIC. And in fact, that's what we write in these first 6 columns, which need to be left blank, or they may contain a line number, like in this case. And then here we have some conditions, and essentially this is the same algorithm which we had in Pascal and originally in C. So here is the first function, isPrime, which is, for example, is being called here. So let's have a look at the rest of the program. Here it is, and so there's another comment, and again, these are all local variables. These, on the other hand, these are the variables in the common block, and so there's another quirk of Fortran. You need to redeclare what's in the common block in every procedure or function which uses them. Subroutine is the Fortran name. So again, rather a weird quirk of Fortran, but so in Fortran essentially everything is local, except when you declare something to be in the common block, and then you need to redeclare it. And in C that would be akin to all of these functions each having their own header file, something along those lines. And that's the only way that these variables will actually be common, shared between the main routine and the subroutine. So that's what we do here, and then we have this writePrime, which is the final subroutine. So let's have a look at that, and that simply uses that formatting statement, which we saw before, but in this case we're formatting both a string and a number with 3 places. So here we see the string and here we see the number. All right, so after a lot of trial and error, this is the correct syntax, which actually compiles. So let's do that quickly now. Board edit, yeah, we don't want to change it anymore. And so let's put the first pass compiler back in the A drive, there we go, and run it. Oh, made some mistake. What did I put in A? I put the Pascal compiler in there. So I obviously need to put the FORTRAN compiler in the A drive, this one. There we go. So that should be better. Small trick, you can use F3 to reprint the previous line. That's something you learn if you read the DOS manual. All right. So source file this time is primes. Primes object is fine. No listing, no assembly listing. And that will run the first pass. And as you can see, I've gone ahead and taken out all the errors. We need to now run the second pass compiler on these intermediary files. Let me just show them quickly. So once again, it's created these intermediary files. So here's the second pass compiler, and now let's run that. All right, so that has now produced a primes object file, and so again we need to link that using the Fortran standard library. And so this time we do a link. And we link the primes object file into primes executable, that's fine, no listing. And again, the standard Fortran library will be automatically picked up. All right, so that has now produced a primes executable, and if all went well, that should produce all the prime numbers up to 256. And there we go. And speed is comparable to what we had in BASIC and Pascal, because once again, this is compiled code. So it's a machine language, no translation necessary. And it's linked with the standard Fortran library, which is also machine code. So it's as fast as it's possible to do things in Fortran. Very well. So we've actually run now another compiler this time without access to the manual, and so that's a kind of a testament to the let's say the standard structuring of IBM's various language and development tools for the personal computer. So by first looking at the basic compiler and then the Pascal compiler, we kind of get a general feel of how software development is supposed to happen on the DOS environment on the IBM Personal Computer. And it happens to work equally well for Fortran. So the steps generally are to create a source file using edlin, then to compile it in either one pass, if it's basic, or 2 passes for Pascal and Fortran, which gives us an object file. And then in the final step, we need to link it with some standard library, which is part of the language, which produces an executable. And so that applies to every language that we've seen so far. Now let's look at the second mainframe language, COBOL. The common business-oriented language, which IBM made available on the personal computer. Once again, when we look at this WinWorld PC site, we'll find, so previous page here, a version of a COBOL compiler for the IBM Personal Computer. And so when we download that, I'll show you once again what we get. We get actually 2 diskettes this time. No, in the master here. So COBOL comes in 2 diskettes. Let's have a look at them. So okay, that contains a whole bunch of files, and there's another diskette, which is this one, and that simply contains libraries and some linker related stuff. But most importantly, we do actually have a version of the manual here, which we can have a look at to understand a bit more about this COBOL compiler, and in fact about the COBOL language. Now this manual is 448 pages long. It's a very thorough manual which explains all of the quirks and all of the features and statements and syntax of the entire COBOL language, which is available, or the version which is available on the IBM Personal Computer here. First, a little introduction, then there's some general information about COBOL languages. So COBOL is a very verbose language, and so everything you write is strictly divided into divisions and paragraphs and sections, and they all have very long names. All of the statements are written in a very verbose way. Theory at the time was you want the source code to be almost self-documenting. Now it misses that target in a few instances, but the general philosophy of the language is write as much information in English to try and make the program as readable as possible. And so that leads to a very verbose code. And so all of that syntax is explained here in great detail in all of this manual. So obviously I'm not going to go through all of these 400 pages in this episode. In fact, you can look at this manual yourself if you want to learn about the language. I've gone through all of the bits which I needed to write some of the sample programs which I want to try out. And so we'll have a look at those based on source code, which is an easier way. But a developer in 1981 or 1982, whenever this compiler came out, I think it's 1982, would have had access to all of this information in the manual here. So what we're going to look at today is, so this is a basic structure of the program, of the source code. We're actually going to learn how to use the tools. And so that's this chapter 3 here. So let's have a look at that. And here it is. So what we need are the COBOL and the library diskettes. So again, we only have one compiler diskette, which is this first one, just as we did with BASIC. And we might want to copy command.com on these diskettes when we make backups. So it's the same story as ever. And so once again, I've gone ahead and done that. So I have copies of the Cobalt Compiler and linker diskettes, and both of those contain the same as the master diskette plus the command interpreter, which comes on the DOS diskette. And I've done the same for the linker diskette. And then we also want a scratch diskette on which we may want to copy the edlin program, just as we did for Pascal, so that we can edit our programs. Again, the COBOL, just like Fortran and Pascal, doesn't provide its own editing environment, so we need the DOS line editor to write programs. So I've also gone ahead and prepared a COBOL programs diskette, which we can have a look at here. So let's go back to the B diskette, which is where I've put it. And so here are some example COBOL programs. We'll get to COBRAN in a minute, and edlin is the line editor, which comes together with DOS. So how do we work now? So here, this is essentially how do you switch diskettes, and so you want to make that the default drive, and all about some DOS stuff, things which we already know. And here is what we do. So we have a program here. Let's say we have hello.com. I can quickly show you what's in there. So this is a COBOL program. You can see very verbose and lots of sections which do absolutely nothing, but they have to be there. And all it does is display hello world on the screen. Fine. So what do we need to do? We need to write a COBOL. So let's put the compiler diskette in drive A, which it is, and just try that, a COBOL. Okay, and so just as with any other compiler, it's going to ask us for the source and the object file name. So in our case, that's hello, and that's a good, and we don't want a listing. And now this is a single pass compiler, so that should produce an object file directly. So this is exactly the same as with all the other compilers. And again, we may have warnings or we may not. Now I already know that this program compiles, so we don't get any errors or warnings. But just as in the case of Pascal, there is a section at the end of the manual with all of the error messages. So if you do get an error, you can look at the text, have a number, and then look up the number in the manual and find more information. And so that's how I've gone ahead and written my programs to make them compile. Okay, and so what do we want to do to link? So same story as ever. We need to change to the linker diskette for COBOL in this case, and that too comes with its own version of the linker. And there it is, and so we want to run that. And so the object file is on the B diskette, is our hello object, which the compiler produced. Hello executable is fine. we don't want a listing, and the libraries, once again, the compiler will have organized this object file to automatically look for the runtime library. Now, in the case of COBOL, there are actually two runtime libraries, and both of those need to be available to the linker. So here's the explanation of what happens. Now, the interesting part in the case of COBOL is what happens next. So we've produced an executable file. And here it is. Now, in the case of COBOL, the relocatable object version, really this object file, but it's the object file which then gets linked into the executable file. So our executable file does not contain 8088 machine code, unlike all of the executable files that we've come across so far. Instead, it's a form of a special object language designed specifically for IBM COBOL instructions. The IBM Cobalt Runtime system runs your programming by examining each object language instruction and performing the function required. This sounds an awful lot like an interpreter. The difference is, the interpreter is not running the source code, the COBOL source code directly, but it's running this intermediate kind of object language, special COBOL object language, which the compiler has put in this object file, in this executable file. In modern terms, we'd call that a virtual machine. So this works an awful lot like Java or C#. So both of those languages, when you compile source code, you get object code, but it's not machine language. It's some standardized virtual machine language, which then a runtime system, both the cases of Java and C#, need to interpret and run and translate on the fly into machine language. So apparently this very early version of the Cobalt compiler on the IBM Personal Computer works exactly that same way. And so the runtime environment is actually in an executable file called cobrun.exe. And as you'll see, I've copied that cobrun.exe from the COBOL linker diskette onto my B diskette here, so it's available to run together with hello.exe. Just as in the case of BASIC, where we had a basrun.exe, it needs to be available, otherwise the hello executable won't run. So right now, if I run hello, then that should produce hello world, but it's actually going to work by using the virtual machine interpreter, which is in this cobrun.exe. So that works. However, if I erase cobrun.exe from my scratch diskette, and I also change the diskette in drive A, let's put, say, the DOS diskette in there, then hello will fail to run. As you can see, it needs to find that cobrun. So let's put it back, and it is on the COBOL linker diskette. There we go. So let's write A, and then it runs. So yeah, a little bit similar to what we had with the BASIC compiler. The big difference is there's no way to avoid it. So it's impossible to compile your COBOL source code all the way into native machine language for the IBM Personal Computer. That is to say, for the Intel 8088 CPU. So in that sense, it's not really a dynamic link library. It's much more like a virtual machine interpreter, as I said, in the situation we have today in Java and C#. So that's an important feature to keep in mind about COBOL. So okay, that's a limitation of the language. It also means executables are actually a bit slower because they're not running machine language, they're running this interpreted language, and there's an interpreter running underneath. And we can see that most poignantly when we look at the second COBOL program, which I prepared, great pains by going through all of the different sections and parts and explanations in this manual. But I did manage to produce a running version of the primes program in COBOL, and here it is. So let's have a look at it. So all of the divisions, once again, identification, a program. So this is the identification division. Then the environment division is empty. And then we have the data division. And a data division in COBOL essentially means the global variable declarations. Quirk of COBOL is that there are only global variables. In contrast to FORTRAN, where we essentially only have local variables and we need to use the common block if we want to emulate something akin to global variables, In COBOL, we have the opposite. There are no such things as local variables. So everything that we define here is used maybe only in a single procedure somewhere, but it has to be defined globally. That's simply the way COBOL works. And okay, so here we have a whole bunch of global variables, and they have to be, so I've subdivided them in this way, so you can put them in various sections. These have no meaning other than making it readable to a user. So I've put what I would consider to be global variables here, and what I would consider to be local variables for the various procedures, which are coming further down in the source code, I've put in this block here. But the compiler honestly doesn't care. It just needs to find the variables somewhere. And then we have all this picture stuff. It's essentially COBOL. What its strengths are is for showing a form on a data entry terminal on some mainframe system, so you can enter hundreds and thousands of records and look them up very quickly by using an organization of disk files on disk in an era before we had database engines, and to be able to manage that stuff quickly. COBOL is useless at doing lean, fast calculations, as we'll see. So this program, what we're trying to do here, is actually not very well suited to... COBOL is not a very good tool to solve that problem. FORTRAN would have been a much better mainframe language for that, as we saw. But nonetheless, we can try it out. And so the reason that we have all these picture statements, essentially, COBOL assumes that all of this global data, which we're declaring here, is going to be displayed somewhere on some form. And so it immediately asks you, how do you want it displayed? And it's very difficult, at least I haven't found a way which works to avoid that. So when I declare a variable, I'm essentially declaring a format to go with it, which I'm never going to use. This is an array, so notice how verbose the syntax here is. I want primes to be an array of picture 999, which is an integer, and I want it 128 bytes in size. And notice how many English words I need to declare that. Anyway, that's just the way COBOL works. We can look further into the program, and as you can see, we can define various procedures and run them. And so this essentially is a remainder equals 1. You would write in C or in Fortran, but in COBOL that becomes move 1 to remainder. All right, and let's just look further down, and okay, and then here we have the various procedures. Okay. Abort. Yes, we don't want to modify anything because I happen to know that program works. So let's compile this primes program. So let's put the compiler diskette back in drive A and run the compiler. So primes this time. Primes object, no listing. Notice this compiler doesn't ask me if I want an assembly language listing, because as we read in the manual, it isn't actually producing machine code. It's producing this intermediate COBOL object language. All right, and now we can link that program. There we are. So we want primes object into primes executable, no listing, and the libraries it'll find automatically. Okay. And so a final thing we need to do is we erased this cobrun.exe from this diskette, so we should put it back. Otherwise we're going to get that same error message again. And it happens to be on the linker diskette, so we can just copy it over. From A, we want to copy cobrun.exe to our B diskette. There we are. It's back again, and so now we should be able to run this primes.executable. And so this is an object file, and as you can see, this is painfully slow. First of all, because COBOL is pretty inefficient at writing these kinds of algorithms, but secondly, this is interpreted. Even though it's an executable file, it doesn't contain machine language. It contains this intermediate language, and we need cobrun to interpret it. So, yep, that's some of the interesting quirks about the COBOL language at the time. So I think even though you can write programs for it, I don't know that many people would have used it unless they had some reason to port over programs which had been running for a long time on a mainframe and needed maybe to do some testing or development or run some stripped down version of existing programs and existing source code on their personal computer. And I think that would have been the main use case for this environment. But it's a perfectly valid programming environment which is available, and so we've just seen how we can get it running. Okay, so I think we're about done now with the various high-level languages which were available on the IBM Personal Computer. I didn't find many others, so we have BASIC, we have Pascal, we have FORTRAN, we have COBOL. There may be some other exotic high-level language which I've overlooked. C, the most obvious question to ask, was not available on the IBM Personal Computer in 1981. The very first version of C which was available came on 360 kilobyte diskettes and required DOS version 2. So I won't be looking at that in this series. It wouldn't have run on one of these original IBM Personal Computers. So what we're going to do in the next episode is we're actually going to start delving deeper and delving into the realm of assembly language. And so now we're leaving the realm of high-level languages and we're getting closer to the hardware, in particular to the CPU and its instruction set. And that's a rather complex and large subject, so we'll probably take several episodes to go through it. But we'll be starting that in the next one. So see you then. And then you gotta slow